Assalamu alaikum. I am going to prove this theorem over here. The theorem says that if n is an odd number, oh sorry, this is supposed to be n. If n is an odd number, I'm going to rewrite it. In fact, then a plus b divides a power n plus b power n. If n is an odd number, then a plus b divides a power n plus b power n. This is the sign of divide. This sign means that one number divides the other number completely without any remainder. For example, if 4 divided by 2 gives no remainder, we can write it as 2 divides 4 completely. That's what this means. So a plus b divides a power n plus b power n. Okay. And for this purpose, we are going to use a theorem. Sorry, we are going to use a method, mathematical inductions. Using mathematical induction. Okay, mathematical induction. This method has three steps. Three steps. Step one, show that, step one is mandatory. Every step is mandatory, but you have to go order-wise. Like step one, show that the result is true for n equals to 1. Like if we put 1 instead of n, we have to show that the result is true. We have to see that, okay? Otherwise, there's no use in doing that. Step number 2, suppose if this is true, if this part is completed, then suppose the result is true. We suppose that it is true for n equals to k. Okay, now we suppose that the result is true for n equals to k. And then step 3 is, now we have to show that the result should be true for, show that the result is true for n equals k plus 2 or k plus 1 or k minus 1, whatever suits you. Okay, first step, we have to show that the result should be true for n equals to 1. Okay, and then we suppose that n is, well, this result should be true for n equals to k, and then we have to show that the result is true for n equals to k plus 2. Okay, so step 1, we have to see that n equals to 1 holds. All right, replace n by 1. Therefore, a plus b divides a power 1 plus b power 1, and by the uh, by the definition of divisibility, we have a plus b equals c1 times a plus b, and c1 is an integer that is a positive integer, basically c1. Okay, there must be an integer. This is the definition of divisibility. And c1 equals to 1, this implies, therefore the result is true. All right, a plus b equals a plus b. So now step 2, this step is completed. Step 2, we have, suppose result holds for n equals to k. Okay, now we are going to suppose that the result will hold for n equals to k. Therefore, a plus b divides a power k plus b power k. We suppose that this is true, so we name this equation 1. All right, now we completed this step right here. Now on to the third step. Step 3. Now let n equals to k plus 2. We have to show what the result holds for n equals to k plus 2. So we have a power k plus b power k. So we have to show that a plus b divides a power k plus 2 plus b power k plus 2. We have to show that. Now, a power k plus 2 plus b power k plus 2 should be equals to a power k dot a squared. plus b power k b squared. All right. Now this should be equals to this because the bases are same and the powers are adding up over here. So this implies now we are going to add and subtract a number. Subtract first, and the number is a power k times b squared, and we are going to add the same number. Why can we do this? Because it makes no difference if there is an equation like 5 equals to 5, 5 equals to 5. So this means that 5 equals to 5 plus 3 minus 3. All right, this doesn't make any difference, so we can absolutely do this. And the reason for that you will get to know in a while. From this and this, we take the number a power k common, a square minus b squared. All right. Now we can also take a power k common from this number, but we have to take it common from the number that has a minus sign, and you will know in a while why are we doing this. Plus, now from this number and this number, we had to take b square common. So we are left with b power k plus a power k. Okay. Now this is what we have. Okay. Now we are going to use another theorem to prove this. Now that theorem says that if a is a number that divides b and the same number divides another number that's c, that means a divides bx plus cy, where x and y are integers. Okay, this is another theorem that says that if a number divides a number, and the same number divides another number, then if we multiply the second numbers by x and y respectively and add them, then the first number, a, that divides the sum of bx plus cy. All right. So what we need is that if a plus b, I mean, we have to prove this, right? This. So if a plus b divides this number and a plus b divides this number, and a and b and k, all three are integers. So a power k plus b power 2, a power k and b power 2, they are also two different integers. So that will be, the result will hold for them. Now a plus b should divide a square minus b squared, and a plus b should divide a power k plus b power k. That's what all this is about. Now, if we consider the formula a square minus b square, this is equals to a plus b, a minus b. That means that if a plus b is equals to some random integer, we can say that a square minus b square equals to c1 a minus b. Using the definition of divisibility, we can say that a minus b divides a square minus b square. All right. We name this equation as a. And using the supposition in step number 2, we had that a plus b divides a power k plus b power k. Now, both of these results are true over here. Now, this is divided by a plus b, and this is also divided by a plus b. And both of these numbers are multiplied by integers, and they are added together. This implies a plus b also divides a power k a square minus b square plus b square b power k plus a power k. And all of this originated from this equation right there. So we can say that a plus b divides a power k plus 2 plus b power k plus 2, and the result holds for this. And hence we can say that our theorem is proved. Thank you very much.